Hello everyone. So today we shall talk about field loading test for stone column. It is also called as load test for stone column. Why we go for the load test? To find out the ultimate bearing capacity or ultimate load on the stone column and settlement, or we can say load carrying capacity of the stone column. So you can see here, irrespective of the method used to construct the stone column, the initial load test should be performed at a trial test site to evaluate the load settlement behavior of the soil stone column system. Wherever you are going to construct the stone column at this site, right? There we have to first go for the load test. How much load the stone column can take it. So next we can see the test to be conducted on a single and also on a group of minimum 3 columns. So both we can consider. Either we can test on a single column or on a 3 columns. So for the initial load test, in order to simulate the field condition of the compaction of the prevailing soil, a minimum of 7 columns for a single column test. Suppose you want to install or construct a single stone column. In that case, we have to drive 7 columns at the site. You can see here 7 columns are there. 1, 2, 3, 4, 5, 6, and in center one column is there. So for single column test, we have to drive 7 columns at the site. 12 columns for 3 column group test may be constructed for triangular pattern as shown in figure. So what we have to do in case of a single column test, 7 columns should be driven at the site, and for 3 column test we have to drive 12 column at the site. You can see this spacing is also given there, 1.85 meter in between the two column, right? And the diameter of the column is also given there, 900 meter. So how we can find out the effective area surrounding the column? Effective area or influence area or a tributary area can be calculated, right, by 1.05 s. S is nothing but it is a spacing. So if you are going to multiply 1.05 into 1.85, we shall get 1.94. What is 1.94? 1.94 is the effective area, right, surrounding the stone column or a tributary area. This is also required to know. Next we can see, as I told you, for 3 column test, we have to drive 12 column at the site. The diameter of the circular concrete footing, right? This is for the 3 column group test. So as I told you, we have to drive 12 column at the site for 3 stone column test. You can see these are the 3 columns given here. The diameter of this circular concrete footing or equivalent steel plate. These are very important things. Circular concrete footing or equivalent steel plate of adequate thickness and rigidity may be based on the effective tributary area. This is the tributary area surrounding the stone column, or effective area or influence area, right? May be based on the effective tributary soil area of a stone column for a single column test, right? For a single column test. This is for a 3 column test. So for single column test, what we have to do, we have to provide the circular column footing or equivalent steel plate surrounding the stone column. That means the circular concrete footing or equivalent steel plate. The diameter of these two things will be equal to the effective area of the single stone column, right? Suppose we want to test a 3 stone column test at the site. In that case, 3 times the effective area of the single column. Whatever the effective area we have achieved for a single column in the previous slide, we shall multiply by 3 to get the effective area or tributary area for the 3 stone column. This we have to remember. In each case, the footing may cover the equivalent circular effective area centrally. That means what? The footing means what? The concrete footing or steel plate, whatever we are going to use. The diameter or the dimension of this concrete footing or steel plate will be equivalent to the effective area or tributary area, right? What is the tributary area? As we have seen for a single stone column in the beginning in the previous slide, that is equal to the effective DE is equal to effective area is equal to 1.05 into a spacing, right? And we by multiplying that one we are going to 1.94, right? So these things we have to remember. Now we can see this test we have to perform. The load test on the stone column we have to perform. Before starting the load column test, what we have to do? We have to also go for the initial and final soil condition at the trial site should be investigated by drilling at least one borehole. What we have to do? Where we are going for the load test for the stone column. In that case, we have to at least we have to make a one borehole sample to find out the geotechnical properties of that soil. So one borehole and one static cone test or pressure meter or dynamic cone test prior and later to installation of the stone column. Before installation of the stone column, also we have to know the geotechnical properties of the soil, and even after installation of the stone column, also we have to know the geotechnical properties of the soil. We have to collect the soil samples. We can see all these tests including the SPT, standard penetration test also we have to carry out. Field vein shear test, collection of undisturbed or disturbed samples, right? To analyze that sample in the laboratory, right? And laboratory testing on the sample should be the testing definitely should be carried out as per the relevant standard, relevant country standard or Indian standards. So we can see here once we know the effective area, then what we have to do? We have to go for a granular blanket of medium to coarse sand having thickness not less than 300 millimeter should be laid over the test column. Suppose we are going for the single stone column test at the site. So in that case, what we have to do? We can see this is the granular blanket of 300 millimeter. So before starting the test, we have to construct the stone column, right? And above that, we have to spread the medium to coarse sand, right? The thickness of this coarse sand or medium to coarse sand will be 300 millimeter, right? And after that, over the blanket, this is called as blanket. This 300 millimeter, the thickness of the gravel or sand, the medium to coarse sand is called as blanket. A properly designed footing should be laid. So this is the footing. Above that, we have to put the footing, right? And the footing should be the concrete footing or the steel plate. The footing may be cast away from the site, test site. We can also cast the concrete footing away from the site. What should be the dimension of the concrete footing? It will be equivalent to the effective area of the stone column and transported to the test location so as to fix it properly on the sand blanket. So this is the, you can see, concrete footing or suitably stiffened steel plate. Either we can use the steel plate or the suitable size of the effective areas, the size of the whatever the effective area size is there. Accordingly, we have to prepare the concrete footing for the load test. Next, we can see, suppose at the site higher water table is there, right? In that case, what we have to do? the water level during the test should be maintained at the footing base level by dewatering. So here, suppose this is the footing level and water level is there, water table is there. In that case, we have to make suitable arrangement for the dewatering. Dewatering should also be carried out till the test is completed. So further, following procedures should be followed for application of load. You can see this is a footing and this is the column, right? And this is the girder on which we are going to use the load in the form of neltage, right? To determine the load settlement curve or loads test we can say. So here the load should be applied to the footing. This is the footing by a suitable neltage. Neltage is nothing but it is called as sandbags. So this is kept on this girder so that we can increase the load, right? So suitable neltage taking care to avoid impact fluctuation or eccentricity. This is very important terminology, fluctuation and eccentricity. That means this is a stone column, this is a granular blanket, above that footing is there, which may be a steel plate or the concrete footing, right? Above that column is there. Above column we have put the girder, right? By giving the support with the this sandbags. And above that we have to place the sand nelted in such a way so that it should not create the eccentricity. Suppose you are putting in the beginning you are putting the neltage in the form of a sandbags uh, at the edge. In that case, eccentricity may take place. So fluctuation and eccentricity should not be there while loading the neltage. Okay, the neltage should be minimum 1.3 times the maximum test load. Whatever the maximum test load you are going to use at the site, so at least 1.3 times neltage load should be used. The neltage should be minimum 1.3 times the maximum test load which you are going to use at the test site. Next we can see load settlement observation should be taken to 1.5 times the design load for a single column and three columns group test especially, right? Suppose design load is 25 ton. So in that case, we have to multiply by 1.5 times, 25 into 1.5 times, right? That load, up to that load, we have to go for the load settlement test. The settlement should be recorded by 4 dial gauge reading. You can see the 4 dial gauges are there, and this is the steel plate or the concrete footing. On that footing itself, we have to install the 4 dial gauges. And suppose it is a rectangular or the square footing. In that case, each corner we can put the dial gauge, right? And the dial gauge, the division of the dial gauge sensitivity, it should be less than or equal to 0.02 millimeter, fixed at diametrically opposite ends of the footing. Next we can see each stage of loading should be near about 1 by 5 times of the design load and should be maintained till the rate of settlement is less than 0.05 millimeter per hour, at which instant the next stage of loading should be applied. What does it mean? That means each stage we have to apply the load in a sequence form, and what it says that each stage of the loading should be near the 1 by 5 times of the design load. Suppose design load is 25 ton. So 25 by 5. So 1 by 1 we have to put the load on this in the form of a neltage, right? So that means 5 ton, 5 ton, 5 ton. Each time we have to put the load in this way, and should be maintained till the rate of settlement is less than 0.05 millimeter per hour, at which instant the next is, that means Suppose you have put the 5-ton load on this in the form of a null test. So you have to wait till the settlement rate of settlement is less than 0.05 millimeter per hour. These things should be taken care of. So the design as well as the maximum test load should be maintained for a minimum of 12 hours after stabilization of settlement to the rate as given below. The design as well as the maximum test load. Once you have put the load on this girder, it should be kept there for the period of 12 hours, right? What it said that should be maintained for a minimum period of 12 hours after stabilization of settlement to the rate as given in E. In the previous section E, right, we have to maintain for the period of 12 hours. Next paragraph we can see how we can note down the dial gauge reading at different timing. Load settlement and time settlement relation should be plotted from this settlement. Observe for each increment of load at intervals of 1 minute, 2 minute, 4 minute, 8 minute. So this timing we have to put the load, and after putting the load at a different timing we have to measure the settlement with the help of dial gauge, and so on till the desired rate of settlement has been achieved. The time intervals may be suitably modified. So this timing can also be modified as per our requirement. The test should be unloaded in 5 stages. Once we have completed the loads on the load settlement criteria, we have completed the loading on these stone columns, and we have measured the load settlement data in the tabular form. Then we have to start for unloading in 5 stages. At each stage, enough time should be allowed for settlement to stabilize. Every time we have to take care of the stabilization. So at each stage, we have to give the enough time, right, to stabilize the settlements. Now we can see the load test should be considered acceptable if it meets the following settlement criteria. What are the settlement criteria as per the IS 15284 part 1 203? So these two criteria are there. For single column, the settlement should not exceed 10 to 12 millimeter settlement at design load for a single column test. Design load suppose 25 ton is there, so it should not exceed 10 to 12 millimeter. In case of 3-column group test, the value should not exceed, the settlement should not exceed 25 to 30 millimeter, right? So once we collect the data in between the load and the settlement, then we can plot the graphs to find out the bearing capacity, ultimate bearing capacity, and the settlement. So you can see one thing here I would like to say, that we have put the load for the testing on this girder in the form of a nail test. So what area, how we can find out the pressure? You can see here the pressure kPa is given there. So load divided by this concrete footing area or steel plate area. So load by area we can get the pressures, and so on this axis we can plot the pressure. This is the x-axis, we can plot the pressures, and on the y-axis settlement. So we shall get the graphs. For you can see the single column, the graph is given in the form of a dotted line, and in the form for the 3-column test, the solid line is given there. So wherever this graphs moves downwards, we have to plot a tangent here. We can plot the tangent at this line and tangent from this line. Wherever it cuts, we draw a vertical lines. The vertical lines cuts on the x-axis, which will be the ultimate bearing capacity. And accordingly, we can also find out the settlement. So the load test is used to find out the ultimate bearing capacity and settlement on a particular bearing, ultimate bearing pressures, right? So this is all about the today lectures. So what we can say finally, the load test on the stone column is carried out to determine the load carrying capacity of the stone column, right, and the settlement. So thank you.